let's go to the next one. You have been given the derivative. And notice it's in two pieces. This is a little piecewise. And you're probably thinking of something that I have mentioned earlier, that the derivative of an absolute value is going to look like that. And technically, the original function is more than likely absolute value. And because of that, it actually would be absolute value. And because of that, it can be written as a piecewise, so the derivative is also piecewise. So there we go. That's where we're beginning. I like to start with the thing that is the easiest. And so in this case, I'm going to graph the derivative of the derivative, which is the second derivative. So the derivative of this, okay, what's the slope of this? 0. Okay, easy. I'll graph 0 up to but not including -1. Because the function does not continue, the derivative of the function is not continuous at 1, or -1. So I can't talk about the derivative of the derivative because the derivative doesn't even exist there. What's the slope here? 0. Okay, wow. All right, that was a very, very boring second derivative. So there is our second derivative. Now things get a little spicy. Ah, fun stuff. The slope of this piece, it was 0. Sorry, I was backtracking. The slope of this piece was 0, but this is the slope of something else. All right, let's think back for a second. Let's just look at this part. This is a constant, right? Other than 0, it's a constant. If I get a constant, then I started with something that was linear. If I get a constant here, I started with something that was linear. So the derivative of something linear gave me this. The line that I had, f of x, the line was decreasing. Let's spell it correctly, with a slope of -1 y value for all the x values less than -1. Okay? If I have a consistent slope, I have a line. All right, let's think through this other part. F of x is increasing. How do you know it's increasing? With a slope of +1 for all the x values greater than -1. I haven't written because. I will in a second. I left a little gap here, not intentionally, but I'll take that gap to write down why. You don't have to write all this. I'm just articulating my thinking. So the function is decreasing for x less than -1 because the slope is negative there. So because f prime of x equals -1 on that same interval. And same thing here, because f prime of x is equal to +1 for that interval. Okay, so let's talk about it one more time. Derivative. I want the original function. The derivative is -1. Consistently, for this interval, is -1. Therefore, whatever graph I'm about to draw better be a line, constant slope, with a slope of -1. So, pencil time. I'm going to have, well, I'm trying to draw it right. That. Okay? Slope of +1. I'm going to have that. Do they meet? I don't know. I think I accidentally said earlier that it's almost definitely absolute value. It is not definite. I might have said definitely. Anyway, it is not definite. Maybe what I have is this. Maybe what I have is this. I'm going to pretend like it is absolute value because it might be and it might not. And again, it might be here. It might be here. It goes back to what we did in the previous problem. When I take the derivative of something, something, something with a vertical shift, that vertical shift is a constant, and I take the derivative of a constant and I get 0. So I have no way of knowing, given this information, whether my original graph was here, 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 or again, here, here, here. Maybe it was a piecewise that wasn't absolute value. So let's draw it. And it was blue. So slope is 1. Slope is 1. I have drawn something that has that is continuous at x equals -1, but its derivative is not. Okay.